In this video, I want to talk you through paired t-tests. So what they are, when you would use them, and how to perform them in R. So a paired t-test is used to look at the statistical difference between two variables of the same subject. So it's normally used to determine whether the mean difference between two sets of observations is 0. So it's testing here, if you look at this figure, where there's a difference between the means here and the difference, and whether that's significantly different to 0. So in a paired sample t-test, each subject or entity is normally measured twice, resulting in a pair of observations. You then look for the difference of these and test whether this is different to 0. So the null hypothesis is there's no difference of the observed mean difference and 0. And the alternative is that there is. And then again, remember to think about the assumptions of the t-test. So go back to that first video on the t-test. When might you use this? So you might use this, for example, and we'll be looking at when researchers wanted to check the average blood cholesterol value of women and looked at this before and after a treatment. So they're going to be pairs of observations because it's the same woman who's been tested before and after the treatment. Sometimes this can be differences in years, so they might have looked at a patient in 2010 and then looking at them again in 2020. But because it's the same subject, we would use a paired t-test. So let's have a look and see how you would do this in R. So I'm still working on from the previous video, so I'm still in my working directory. I'm going to call this data frame col treatment because we're looking at the difference in treatments before and after and see if there's been a change in cholesterol level. I'm going to use read.csv and read in that data set called co-treatment. So you can see it's appeared here. We're now just going to have a look at what the names are in that. So col before and col after. If I pull that up, you can see that we've got the cholesterol level before in the left column and then the cholesterol after in the right-hand column. And this is how that data should be set up to do a paired t-test. We then need to again check those assumptions, so check whether they're both normally distributed. Because they're in separate columns now, we don't have to subset them. We can just do a histogram on each column. So if I do and look in plots, so yeah, we can say just by eyeball, this looks like it's following a normal distribution, so that looks okay. After, yes, this generally looks okay as well, just by eye. And for the t-test, you guys will be familiar with this already. So we're using that t.test function again. And here we just give it the x and then the y that we're looking at. So we're looking at a cholesterol treatment data set, and we're looking at the cholesterol before column. And we're comparing that to that cholesterol treatment and that col after column. And what we then need to put into the argument is that paired equals t. So paired equals true. So these, when they're doing the t-test, it should be paired. And you can also add in that alternative we looked at in the previous video for the 2 sample. So if you want it to be 1-tailed or 2-tailed, you can add that in here as well, if you expect it to be higher or lower. So if we run this, you can see that it's then printed me that paired t-test. And the data that we looked at was that cholesterol before and then that cholesterol after. And again, it's given me a t-test statistic. It's given me my degrees of freedom and my p-value. So remember again, report this in standard form. Always put p is less than 0.001. It's telling me the alternative hypothesis is that there's a difference in the mean not equal to 0. So you can see what the mean of the differences is, so 3.32. And based on this p-value, we know that that is statistically significant from 0. So that's how to do a paired t-test in R.